Alright, Mr. Claxton's Algebra 2 CP students, what we're trying to do today is solve word problems with systems of equations. What do you need to know? You need to know how to identify what the question is asking, how to identify that given information as well as the implied. There is some implied information as well that you need to know. We're going to speak very briefly about some of the examples. Feel free to pause at any time if you want to see some of these slides and read over it. Just pause so you can see it, because I'm going to be clicking through very quickly. How to declare and identify variables. Okay, translating given information to two equations. Now this one right here is what many students are struggling with. You know, and here's how you get better at this. You get better at this through experience. So doing many more problems. So I hope that you do as many problems as possible on that or with that packet that I send home. Going ahead and starting with example 1, and feel free to pause at any time. I'm not going to read them to you. What I am going to point out is the implied information here, the implied information. So after reading this, the implied information is that we have 6% of 500. So we have to calculate that 6% of 500. Multiplying those is implied. Now understand, I really didn't even need to consider that until I got well into the process. Because first, I identified my given information, okay, based upon what the question was asking. I defined my variables. Then I created the first equation, the easiest equation. If there's 500 milliliters of solution, I know x plus y has to be equal to 500. This equation is a lot tougher. We've got to take that given information. We're combining the 10% solution with the 4% solution to get 6% of a 500 milliliter solution. And some students are able to get the percentages, convert them to decimals. But this part right here, that 6% of 500, is what we struggle with. After we multiply 6%, or 0.06, times 500 to get 30, we can set up our system. Now from this point right here, some of you might not like the way that decimal looks, and really in order to solve this by using elimination, you need to multiply equation 2 by a value to get rid of those decimals. So we multiply by 100 to get rid of those decimals, and on this slide, this is what the work looks like. So feel free to pause, digest it, maybe try it on your own, and then look back at the solution. Here's another example of a chemistry problem. Feel free to pause, take a look at it, maybe pause, try to answer it, and then move on. Here's how the equations are written. Notice that we multiply by 100 here, and the reason why we multiply by 100 is to get rid of those pesky decimals. And that does create a big number for us, 2,500. And understand that we multiply by -4 up here, because after I did this first, I multiplied this bottom equation, equation 2 first, to get rid of those pesky decimals, and then saw, after I rewrote it, oh, I can multiply by -4 to eliminate the y's. Make sure that you multiply everything in equation 1 by -4. If you don't, then you'll get some different answers. And again, I'm just going to go ahead and click through the slides so you can stop and review them on your own. Just make sure, pause and come back. Please make sure you come back to us. Again, we have some implied information. The implied information in this particular problem is that they were selling the mixture for $1.35 per pound, and they knew that they wished to have 1,000 pounds of the mixture. So if they want 1,000 pounds, and they're selling the mixture for $1.35, that $1.35 times 1,000 is how much they're bringing in. Okay, how much they're bringing in. So $2 per pound of mixture multiplied by the amount of $2 candy, X, increased by 75 cents multiplied by the amount of 75 cent candy in pounds. When we add that together, we get 1,350. That's going to give us how much they're making. And that comes from some implied knowledge there. If you look at the top, okay, with the top, that's how we would solve it without even getting rid of that pesky decimal, 0 and 75/100ths. If you want to get rid of that pesky decimal, if that's just what you do, then look at the bottom. Okay, in the bottom down here, you see 200 multiplied by X plus 75Y, and that creates a really big number, 135,000. It will still come out. You'll still get the right answer, but you are working with bigger numbers. And I'm just going to go ahead and click through the rest of the slides. In the consumer economics question, having a visual for this one is very important. We create the two options, and really the question, it's saying which option do you think is better, and it really depends on your reasoning, because at the point 211, which is where these intersect, these two lines intersect, that's where they're the same. So after 2 hours, one of the options is going to be more expensive. Because remember, what does Y represent? Because we made this a two-variable system, Y represents money spent. So our money spent is going to be greater all the time beyond 2 hours. If we choose option B. Okay. Option A is the cheaper after 2 hours. So you have to, you know, and I write it a lot better down there in that pink color. So again, you know, this is meant to help you. This is meant to give you more practice at, you know, something that some of you thought we really knew and really had a firm grasp on until we saw a bunch of different types of problems. So happy equation solving. I hope this helps you.